Yeah. We're going to start off from where we left off the other time. So if you've got any problems to it, let me know. So with the other questions, were you okay with all of them? The previous question.
Um, yes, I was able to solve it. It was just one that had forces like I. It had forces inside.
Yeah, I think there was one that has got work, energy, and power. Yeah. Let's see that question. Which question number was that?
Okay. I don't know the number, but I know it was 2016 winter.
2016 winter. Okay,
Yes.
let's look at this one. I'm definitely going to look at that one. So
Mm.
let's look at this one first. You're able to solve this, right?
Let me see. Let me look for. Yeah.
As the same, we move on. If it's not the same, then we
Um,
have to start together. 2018, Apple 3. Let me see. 2018. I wait for now. 2018, Apple 3, question 7. Oh, okay. It's going too difficult. You should get your final answer to be negative 30.
you said
You should get your final answer to be negative 30. Well, that's what
which
I
one?
got. This
The I.
very question. Yes. Can you see my screen, please?
Yes, I can see it. I
Okay.
can't find the question. That's why. Because
Yeah.
I solved all the questions I took the screenshots of. Okay, I've seen no this question for.
Oh, a particle moves in a straight line. The particle is initially at rest at point O, blah, 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 blah. Okay, let's solve it. Let's solve it. Since you can't find it. So let's, is that okay?
Okay.
Okay, so any ideas as to how to go about this? A particle moves in a straight line. The particle is initially at rest at point O on the line. At time t-seconds after leaving O, the acceleration a meters per second of the particle is given by a is equal to 25 minus t squared for a between the time interval of 0 and 9 seconds. Find the maximum velocity of the particle in this time period. So maximum velocity, what can we say for maximum
Um,
velocity?
acceleration is zero.
Okay, for mass velocity, acceleration is equal to 0. And we're given the acceleration function, so this should be easy and fun. A is equal to 25 minus t squared. And you can do your manipulations. I think the only way this can be 0 is when t is 5.
Yeah.
T is positive or negative 5. But we're not going to take the negative aspect of time. You know what that means.
Yeah.
But we're going to find the time at which the velocity is maximum. But we need the time to find the maximum velocity. So we've got an acceleration function, and we want to get a velocity function out of it. What do you think we need to do to get a velocity function out of an acceleration function?
You have to integrate it.
Okay, so Diva, you differentiate displacement function, you get velocity function. You
Yeah.
differentiate velocity function, you get acceleration function, and the reverse. So because we've got acceleration function, we need to integrate the acceleration function to get the velocity function. So this one v is equal to the integral of 25 minus t squared dt. Okay, so do the integration for me.
Okay, that will be equal to v is equal to 25t
Okay, v is equal to 25t
minus
minus.
t raised to the power 3 all divided by 3.
Okay, so let's write it 9. 1 over 3 t raised to the power 3 plus v naught.
Yeah.
But I think we're given a condition, right?
Yes.
When I think the first statement also,
Yes.
the particle is initially at rest.
Yes.
Yes, at this point, the particle is initially at rest. So we can use that one to write out an initial condition. So when time is equal to 0, the velocity of the function was 0.
Yes.
So when t is equal to 0, velocity was equal to 0. If you do your substitution, you solve for v naught and you realize that v naught is equal to 0. Is that okay?
Yes, please.
So we can use this one to write out our new velocity function. So my velocity function now becomes v is equal to 25 t minus 1 over 3 t cubed. Yeah, that's all. We're told to find the velocity, the maximum velocity. So there's the velocity function, and I know the time at which the velocity is maximum. So the time at that time t is equal to 5. So all I need to do is to sub this into this, and I'll be good to go. So maximum velocity gets v to be equal to 25 multiplied by this 5 minus 1 over 3 and 5 raised to the power 3. And I think you should be able to simplify this.
Yes, that's 83.33 meters per second.
So v is equal to 83. Is it a recurring 3?
Yes.
83.3. So let's do it this way. Yes.
Mm.
To tell the examiner that you know what we are doing. Okay, good. So that was the first question. Let's see if there are more. Yeah, there are more. Find the total distance traveled until the maximum velocity is reached. This is interesting. How would you do this? Find the total distance traveled until the maximum.
Okay, so that means we'll integrate our velocity function to get a displacement function. And here they said from rest to s not will also be 0.
S not equal to 0.
Yes.
Okay, but you see, Derek, I don't know about you, but me personally, I don't really like dealing with the constant of integration. So whenever
The time.
set up as a definite integral, especially when I'm finding the displacement, I just go for the definite integral instead of an indefinite integral. Then I start worrying myself over constant of integration. So this is very true. I know the time at which the particle is to achieve attain or achieve the maximum velocity. It's when t is equal to 5. And definitely the time is going to start from somewhere. It's going to start from 0.
Yeah.
So setting up this, I'll set up this as a definite integral, not an indefinite integral. So s in this case is going to be equal to integral of v, which is 25 t minus 1/3 t cubed dt. But with this one, the limit of integration will be 0 to 5. So that I don't worry about constant of integration. Is that okay?
Yes, please.
I don't know. Everyone has got his own old style. So I don't know if you're going to go with your own or you pick this one. I think it's very safer compared to what you are doing. But what you are doing is not actually going to be wrong. You are going to get the same answer. But I prefer this one to that.
Thank you.
Okay. What would this give you? And also with this one, I can use a calculator straight away. So you can just point this on the calculator and you get an answer. But you should know that you are going to get marks for it, so you are not expected to use the calculator.
I got 25 divided by 2 t squared minus
25 over 2 t squared minus
t raised to the power 4 divided by 12.
t raised to the power 4. So let me say 1 over 12 t raised to the power t raised to 12 t raised to the power of 4. Okay. So from 0 to 5. So you can put in your limits and you get something nice to work with.
Yes, and that was 260.42 meters.
Okay, 260.42 meters. Okay, maybe when we start dealing with the Newton's, the laws of motion, I'll start asking you to leave the answer in 3 significant figures because that's what is required in your final paper so that I get used to that. I have never really said anything about that because I just want to build the concept, and I feel that working with a more accurate answer in math is better than with approximated figure. And that's why I've not said anything. But for exams purposes, we need to stick to what the exam rules are. Is that okay?
Yes.
Now the next part says that find the velocity when a particle find the velocity of the particle when t is equal to 25. How are you going to do that?
Okay. Um. Here they said the acceleration of the particle when t is greater than 9 is given by that function. So
Okay.
we can use the velocities as the linking this thing.
Okay. The
Right.
linking is here. The time over here, there's 9 and there's line. So we need to link the two functions. So with this one, I can say that when t is equal to 9, when t is equal to 9, what is the velocity? Just substitute 9 over there so that we get a velocity of that function. So this becomes our initial value that we're going to set, use to link up the two functions. Is that okay?
Yes, please.
So all you're doing is substitute 9 into this function. So v in this case will be 25 multiplied by 9 minus 1/3 of 9. That's going to give you a negative value because 9 cubed, dividing 9 cubed by 3 and taking that out of 25 times 9, I thought you're going to get a negative answer. Yeah,
Yes, it's negative 18.
negative 18. So that's negative 18 meters per second. Now let's deal with the question. We're given the acceleration function in this case to be negative 3 t raised to the power negative 1 over 2. And we're looking for velocity. So definitely we're going to do some integration over here. So the velocity of this is going to be the integral of, don't find anything, the integral of negative, okay, what is wrong with me today? Okay, the integral of negative 3 t negative 1 over 2 dt. So do the integration for me nicely so that I put in the values and they are good to go.
Okay, so that's negative 6t raised to the power 1 over 2.
Negative 60,
Negative 6t raised to the power 1 over 2.
negative 6t
Yes,
raised to the power 1 over 2.
1 over
So
2.
basically negative 6 with t.
Yeah.
Anyway, plus a constant of integration, v naught.
Mm.
Now, this is where we're going to use the linking values. So when t was equal to 9, velocity was equal to 8, negative 18. So I can substitute those values over there, negative 18, negative 6, of square root of 9 plus v naught. And this should give you the velocity, the initial, the v naught over there, the constant of integration. So what's going to be the v naught?
Mm.
I think it's going to be 0. Square root of 9 is 3, 3 times 6. Negative 6 is negative 8. And this should be 0. This is going to be 0. There, that is 0.
Yeah. Yeah.
Yes. 0. Okay, so let's move on. We are told now I can set up the function. Again, the velocity function should be v is equal to negative 6 with t plus 0, but I don't really need to write the plus 0. Now we're told to find the velocity when the time was equal to 25, or yeah, I think so.
Yes.
Find the
Yes.
velocity when the time was 25. So all I need to do is to substitute 25 over there. So v is equal to negative 6 or square root of 5, and this simplifies to negative 18 meters per second. So negative 30 meters per second as a velocity. What can you tell me about that? The position of the particle. What can you tell me about? What is the particle doing actually? to have a velocity of a negative figure?
Um, it's
It's
oh,
basically moving backwards. It's moving
yeah.
backwards.
Hmm.
You're thinking about this one, Derek. It's
I
moving
wanted
backwards.
yes, I
Yes.
wanted to say it's slowing down, but I changed. I was
That will be something else.
hmm.
Yeah. Okay. So let's its acceleration when it's negative, you can say that it's slowing down. Okay. Let's move on to another question. I think we've done justice to question 8. I've got more questions actually. Question 9. A particle moves in a straight line. Have you solved this one too? 2008 in winter. 4 1 question 7. I think
Yes.
we solved this in the physical class, not online class. Do you remember? I think we solved this before.
Um.
When I came around,
Yes.
you know, let's solve it again. Let's solve it again. I think you even did this without my assistant. Okay, let's take the question. A particle moves in a straight line starting from rest from point O. The acceleration of the particle at time t seconds after leaving O is a meters per second, where a is equal to 5.4 minus 1.62 t. I find the positive value of t at which the velocity of the particle is zero. Giving your answer as an exact fraction. So let's do justice to this question. When the velocity of the particle is zero. So I can just integrate this one or differentiate,
Yes.
which is
Integrate.
we are going to integrate. Okay. So we can say that the velocity v is going to be equal to the integral of 5.4 minus 1.62 1.62. So please do the integration for me. This should be very easy. It's a little
Um.
integral.
That was v is equal to 5.4 t minus 0.81 t squared.
V is equal to 5.4 t minus
81 t squared.
0.81 t squared plus initial constant of integration v naught.
Yes.
So in this case, we were given a condition when t is equal to 0, v was equal to 0 from the
Yes.
statement rest. So basically, I don't really want to do all that calculation again. I guess 5.4 t plus 0.81 displacement 0.81 t squared. There's a velocity function. Now
Yes.
we're told to find the positive value of t at which the velocity of the particle is 0. So when this is equal to 0, because 0 is equal to 5.4 t plus 0.81 t squared. At this point, I don't really look out for factors. I don't look out for factors. Most people will look out for factors. So I just factorize the t out. I don't even bother myself with this. I'm not solving a quadratic. I don't know how to say it, but for me to make life easy, I just factor out the t. I don't even care if the numbers are factors of each other. Plus 0.81 t. Derek, are you there?
Yes.
Okay. So I think you can solve this from there. So please do that for me.
T is equal to 0 and t is equal to 20 over 3.
Okay. So t is equal to 0. Okay, my t is equal to 0 and t is equal to 20 over 3. Okay,
Yes.
second. So that is the first question. We've done justice to that. Find a positive, okay, giving your answer an exact fraction. Yeah. So for 4 marks. Oh, cool job. The next one says that find the velocity of the particle at t is equal to 10 and sketch the velocity time graph for the first 10 seconds. This is interesting. This is interesting. So any ideas as to how to do this? I think this one is
Um,
easy. When you have the velocity function already and we're
yes.
given the time, I can just substitute in and get the velocity over there.
Yes.
So velocity function was is equal to 5. plus 0.81 t squared. So when t is equal to 10, v should be equal to 5.4 times 10. This will be 54 plus 0.81 times 10 squared, which would be 81. So 54 plus 81, that should be the velocity at that point. Sorry,
So
minus. Is it minus or plus?
it's minus.
It's minus. Yeah, yeah, yeah. So how come I was writing? Yeah, Derek, I think I was. How come you missed this error? This minus at this side I wrote plus because if you use a plus, you should have gotten the time to be negative.
I've already done it here, so I was just looking at it.
Okay. So I was
Yeah.
wondering how you got this one. This minus. Let me just explain this one. This minus. Yeah. So the velocity of this would be 54 minus 81. That should give you a negative value.
Negative 27 meters per second.
Negative.
27 meters per second squared. Hey, no, per second. No.
Okay. Okay. So negative 27
Yeah.
meters per second. Okay. Is that what you got over there?
Yes.
Okay. Huh. Now what else are we to do?
Is that we should draw?
Okay, so we've got 2 points. We've got the starting position and the time at which it starts. So for this one to be more accurate, a more accurate graph, let's look for the maximum velocity. The maximum velocity, and also look at the velocity function. You know your quadratus from additional mathematics. Was the orientation of a quadratic curve with a positive a, assuming the quadratic function can be written as ax squared plus bx plus c. When a is positive, how does the shape look like?
Is a U.
A u, and
Yeah.
when it's negative,
Is the like a flip, it upturned U.
I once told you that it's only in science where positive means bad thing. So
Yeah.
positive is also a good thing. So yes, a smiley face, and negative. People don't like negative. I don't like negative. So negative is a frown face, and positive is this face. Yeah. So this curve is going to be a negative curve. It's going to be this way, of this form. Are you getting it?
Yeah.
Okay. But before that, we need to find turning points. Or let's because we are doing mechanics and not math. What's the name? Pure maths. I won't say the turning point. Instead, I'll say the maximum velocity. So let's find the maximum velocity. So at maximum velocity, um, acceleration is zero, right?
Yeah.
So for max velocity, acceleration is zero. We are given the acceleration function, so I can say that 0 is equal to 5.4 minus 1.62, 1.62 t. So find t for me.
Yeah. It's 3.33.
T is 3.33. So give me exact fraction. I think this can be given as an exact fraction. This
10
should
divided by
be
3.
10 over 3, 10 over 3. Okay, now I can find the velocity at this point. So substitute this into the velocity function and get me a velocity. I'm going to use these values to sketch the curve, to get a more accurate curve. So V is going to be equal to 5.4 10 over 3 minus 0.8 10 over 3 squared. So V is going to be equal to
9.
9. Okay, now let's use this basic information to sketch the curve. Hey, what is wrong? Okay, so we're going to use the basic information we've got over the scalar curve. Now we know the velocity when the velocity at zero. Get black partition. The particle started from rest, so I'm going to start from the origin. Going to start from the origin, and at time t, the first question I think we found the time when the velocity was zero. I don't know if you remember. We got 20 over 2, the first part,
Yes.
when the velocity was zero. So when the velocity was zero, let's say this is my 20 over 3. And also we got a time when the velocity was at its maximum. So this was 10 over 3. When it was 10 over 3, the velocity of the function was, what was the velocity of the function? Let's say, okay, it was 9. We calculated for this one.
Yeah.
Just calculated for this one. Okay, so from this side to this side to B. That's actually 9. And what else? And when it was 20 over 3, what was the, okay, the velocity was negative 27 meters per second. We calculated this value, this value. This is the value I'm talking about. Is that okay?
Yes.
Okay, so I need to extend this line. So the velocity was 27, negative 27. Let's say this is where my negative 27 is at. Okay, so with this basic information, we should be able to scale the curve. Now it's a concave, it's a quadratic curve of this nature. So this is going to be the turning point. This is the turning point, and it passes through this one. No.
Mm.
Getting it
So
all
wasn't
wrong.
it negative 27 at time 10?
Yeah, it was time 10 rather. Yeah, this one was the turning point. Sorry, this one was when velocity was 0. So this side is actually time 10. So I have to clean that. I have to clean this one. This one was time 10, yeah. We calculated for this when the time was 10.
Mm.
No, it wasn't 10, it was 20. Oh,
Question.
I'm coming. Let me check. Okay. When time was equal to 10, yeah. When time was equal to 10. Okay, so when the time was equal to 10, there's the velocity over there, yeah. So that is a curve, over there, and that will answer the question. Now the question went on to say that we have to find something else, not just, we have to find the total distance traveled during the first 10 seconds. So this one you have to be very careful. If you set up this integration with the limit 0 to 10, you are going to get it wrong. Why?
Because that would end up giving us displacement, no distance.
Good. That will end up giving us displacement, no distance. Because a section of the graph is beneath the x-axis, that area is going to be negative. So if you don't take that is going to give you a positive and a negative, and it cancels out. But because we're looking for distance, we need to ignore the negative aspect of that. So you can set up this by saying that the distance is going to be called the integral from 0 to 20 over 3. That is from this side to this side. That is the area of that shape. What's the velocity function? I don't want to scroll back. What's the velocity function?
It was 5.4t minus 0.81 t squared.
0.81 t squared dt. The absolute value of, you know what I'm saying, absolute value, to get rid of any negative.
Hmm.
So the absolute value of integral of 0, sorry, in this case, from 20 to 10, 20 over 3. Oh, that is even going to give us a positive. Or 5.4t minus 0.181 t squared dt. Okay, so do this one for me, and that will give you the distance covered. Any answer for me?
No, I'm coming.
Okay, so I take it that you didn't do it. You didn't do this side.
No,
Why?
it was the graph place that I got the graph one wrong.
Oh, okay.
I didn't know that we'll end up with a curve like this.
So which curve did you use?
I didn't. I just did this like straight
No, no,
from.
no. At
Yeah.
times you also need to, Derek, you need to look at the function, okay? There's not a straight line graph. We're told to sketch the velocity function. There's not a straight line, there's a parabola. Are you getting me?
Yeah.
So there will be cases where this won't even be a parabola, but instead it's going to be a cubic function. So that's why we need basic knowledge from pure maths to continue the mechanics. If you check the mechanics syllabus, they'll tell you we need basic knowledge, some knowledge from pure maths to continue in mechanics. So you should have checked the function. This can't be a straight line function. You should know the difference. A straight line curve, y is equal to, let's say, mx plus b. A quadratic, y is equal to ax squared plus bx plus c, where a is not equal to 0. A cubic, y is equal to ax cubed plus bx squared plus cx plus d, where a is not equal to 0. Quadratic, it goes that way, quintic, and yeah. It continues that. I don't think you're going to get a quartic function to sketch. Well, it's not so difficult to sketch a quartic function. After all, it's just like a quadratic function. So anyway, calculate the calculation and get me the value. And also you have to be very careful because this is going to give you a negative displacement because the aspect of the graph is below the x-axis, and that will be explained in details when you are doing pure maths. It's be explained in details. But for mechanics, you just take it as the graph. That aspect of the graph implies that the particle was moving backwards. That's a negative velocity. So negative velocity, and since the particle is moving backwards, if you don't take care, you're going to get the answer. The answer, if you do this as a whole, you're going to get the answer to the displacement instead of the answer as you rightly said. Okay, just use a calculator so that we move faster.
Hmm.
I think I've got 1 hour. No, less than 1 hour.
Yeah.
Let's move fast.
Okay.
Okay, so if you do this correctly, you should get the first one to be maybe 40.
Yeah.
So 40 plus
Two
absolute of the project.
hundred. 40 plus 200, so 240.
Do that again. I don't think that would be 40. The distance over there, this, the distance over there is too small for 240. It's too big for okay. 20 divided by 3, that is 6.6. 10 minus 6.6. Yeah. You should get something lesser than 40 or equal to 40, not greater than 40. Because the area of the shape shouldn't be so so let's do that one again. Let's do that aspect again. Let me wipe off this and we do that aspect again. I think the first aspect is okay. You got the 40. I also got a 40, so it's okay. But the other aspect is where the problem is coming from. Let's integrate that function. Integrating that function, what will we get?
Um,
So let's bring my big absolute. 5.4 over 2 t squared minus 0.81 over 3 t cubed. We're integrating this over the interval 20 over 3 to 10 absolute again. Or let me just ignore the absolute altogether because later on we can just ignore the negative. So I substitute these values in the top one first. So 5.4 over 2 t squared minus 0. Oh, sorry, not over 2.
I got 40.
Go 40.
Yeah.
So let me just input the values over there. T squared minus 0.81. So there, at times you just need to, uh, you see, this kind of things, getting to know that what you are doing is wrong. I don't know. Naturally, it just comes to me naturally. And I think it's because of practice. If you practice for quite a long time, when something is wrong, you get the sayings that, hey, recheck your work. I don't always get it. At times I may think it's wrong, but it's actually very correct. But in most cases, when I don't really feel comfortable about the answer I'm getting, it's likely it's not correct. I think with practice, you also gain that aspect of mathematics where you're able to correct yourself or know if what you are doing is actually wrong so that you prevent yourself from getting or losing the entire value, the entire score. That's what I meant. So this should be negative 40. So s is equal to 40 plus negative 40. But don't forget that we are taking absolute of this. So s equal to 80 meters. And also, I'm very sure that if you had done this, the integration straight away, you would have gotten from 0 to 10. If you had set up this integration this way, um, if you have set up the integration as s equal to integral of 0 to 10 of 5.4 t minus 0.81 t squared dt, you would have gotten the 0. That alone should tell you that hey, there is something wrong. So that should tell you that in a layman understanding, it means that the particle has not moved anything. Like the particle is at its original position. So if I'm
Yeah.
looking for substance and I'm getting this one to be 0, it either means that the particle never moved between the 0 to 10 seconds, or the particle moved and came back to the original position. That alone should tell me that hey, what you are getting over here, it's not distance, it's actually displacement. Are you getting me, Derek?
Yes, please.
Okay, that is very good. So that's with that question. That was question number 9. Wow. Okay, question number 10. Question number 10. 2016 winter fall to question number 7.
2016. Yeah.
I want this question as difficult. That's why it's question number 10. Did you try solving it?
Check. Yes, I did. Yeah.
What's your final answer?
For I was
Your final
450.
acceleration, I.
I. Um. Coming. I got it as 1.125 meters per second square.
I got the acceleration to be 7.5 meters per second square. So let's see what went wrong. Maybe I'm wrong, maybe you are wrong. Who knows? Let's find out. Okay, a car starts from rest and moves in a straight line from point A with constant acceleration 3 meters per second squared for 10 seconds. The car then travels at a constant speed before decelerating uniformly, coming to rest at point B. The distance AB is 4.5 kilometers. Okay, so there are a lot of ways to do this one. Let me try to sketch. I don't really need to sketch, but let me try to get a rough sketch of the first aspect of the graph over here. I don't really need to sketch. Okay, so let's get lines. Oh, no. Okay. My lines are crooked, I don't know. Yeah. So there's going to be the velocity time graph for the first part. I can use Super to continue that question. I don't even know what I'm doing, but anyway, I feel like doing. The car starts from rest, blah blah blah, in a straight line with a constant acceleration of 3 meters per second square. So there's 3 meters per second square. And now continue with the constant velocity for 10 seconds. Okay, so with this one, let me just set up a super with this instead of using a graph. The graph is going to be lengthy, but I think the super will also complement the graph, so don't worry. The car started from rest, so initial velocity is 0. Moves in a straight line with a constant acceleration, 3 meters per second square. So there's 3 for 10 seconds. So with this one, I can find the velocity over here. I can also equally find the velocity over there by using the gradient. Are you getting me? I can equally find by using the gradient approach. But I like that. So I can say v equals u plus at. And v, the u is 0, a is 3, and t is 10. So the final velocity over there is 30 meters per second. So there's 30 meters per second. Okay, so I want to go with the graph, like I said. If I want to go with the graph, I want to find the distance for the first. From this side to this side, it took 30 seconds. Because I don't want to use a graph, I'm going to use constant velocity formula. You know, the constant velocity, we've got speed is equal to distance over time. Because it's traveling with a constant velocity, that's the formula we're going to use. So I'm not using a graph. I'm just trying to get different ways to solve the question for you. Is that okay? I can use the graph. It will be very easy for me, but let me just use constant velocity. So constant velocity is equal to distance over time. Now the next 30 seconds, t was, so let's say, and the velocity was 30 again. So
Yes.
velocity was 30. That was the velocity we just found. It traveled with velocity for 30 seconds. So the distance is and the time is 30. So with this, we should be able to find the distance. The distance should be 90. S 90. So the total distance covered. Oh, the total distance covered. That we need to find the distance with this what. Are you getting me? This was the first 10 seconds. Hello, Derek.
Yes, sir.
This was the first 10 seconds. I didn't complete what's over there. We left with S over there. So let's complete this part. S equals to ut plus r squared. And S equals to u is 0 plus A is 1 over 2, A is 3, and T is 10. So this is 10 squared. So do the calculation for me. Which means that is 50. And 50 times the rate should be 150.
150.
So S equals 150. So this is the distance traveled in the first 10 seconds. It's 150. And the distance traveled in the next 30 seconds is uh, 90. Sorry, 900, not 90. Because 30 times 30 is 900, not 90. So the total distance traveled, I wasted the time. Total distance equal to 150 plus 900. So this would be 1050 meters. I wasted the time. I could have used wasn't it, the graph straight away after using the gradient approach to find the velocity. I just found the from this to the using the trapezium, way of the trapezium. That would have been easier.
Mm.
So I did all the time for 3 marks. I get me.
Yes.
Yeah, so that would have been it. Anyway, let's continue. Um, this is the aspect that is going to make the work a little bit complicated. When the car has been in motion, has been moving for 20 seconds, the motorcycle starts from rest and accelerates uniformly in a straight line from point A with a speed of v meters per second and maintains the speed for 30 seconds. Interesting. Accelerating uniformly to rest at point B. The motorcycle comes to rest at the same time the car. Okay. Now the question is how long was the car in motion? Because we are told that the motorcycle came to rest at the same time the car came to rest.
Mm.
So they all stopped at the same time. So how long was the motion of the car? You see, from the start of the question, we're given 1.5 kilometers.
Yes.
Yes. So 1.5 kilometers, and that is going to be the total distance, right? The total
Yes.
distance. Let me use the total distance be one. Let's say 1,500 meters.
Yes.
So with this time t, let's say the time over is t, and the total distance is 1500. You should be able to find t for me, right?
Yes.
Yeah, so please do that for me.
And he is 70.
T is 70. You've done that already.
Yes.
Okay, so doing that t is 70. So let me just bring um, the t over there and just put in 70. Okay, now let's look at what we can do about the motorcycle. So let me also try to sketch a velocity time graph for the motorcycle. So the velocity time graph for this one is the motorcycle started 20 seconds later. So it's going to start from the point 20. Is that okay then?
Yes.
Okay, so 20 seconds and traveled at a constant, a uniform acceleration, and it got to the point where v was equal to when the velocity was equal to v. So when the velocity was equal to v, it maintained this velocity for some time. So maintain this velocity for some time, and it came to rest at the same time the the car came to rest. That was given to us in the question. So I
Yeah.
can say that the time that this came to rest, there is also 70. Do you agree?
Yes.
Okay, so in all terms, it took the motorcycle 50 seconds to complete the distance the car completed because
Yes.
they stopped at the same time. So I can also say that the total distance over there is 1500 for the motorcycle. Do you agree?
Yes.
Okay. And I think the question went the question told us that the time for the constant speed was 30 seconds. So if this is t, we don't know the time over here. This should be t plus 30. Do you agree?
Yes.
Yeah, that's the velocity graph. This is going to assist us to solve the question. Let's see. Given that the magnitude of acceleration, I'm reading the question now. Given that the magnitude of the acceleration, a meters per second squared of the motorcycle is 3 times the magnitude of deceleration, is deceleration. Find the value of a. So how will you tackle this one?
Um,
A will be told that a is equal to
so,
3.
so I can make the gradient of one of the sides 3a for the acceleration side 3a and the other one as a.
Okay, so this a and this is d. Let's find a. Let's find a. At this point, this will be t and v, and at this point, this will be 20 and 0. You getting what I'm doing, right?
Yeah.
I'm just writing the points over there. So let's find a. A in this case is going to be equal to uh changing over changing x, and in this case, changing velocity with respect to changing time. So v minus 0 over t minus 20. That is going to be the acceleration function. Let me just write it nicely. A is equal to v over t minus 20. Do you agree?
Yes.
Yeah. Now, before we can even continue, we need to find v. I think that can be found to make our work even before doing this one. That can be found. After all, I know the total distance the motor travel and the total time it took the motor to travel that distance, right?
Yeah.
Yeah, so let's instead of doing this, let's just find the value of v. It's going to make our work so easy. So that is going to make our work so easy. Okay. So let's find v. My quest is to find v. I can now say that the total distance, that is 1500, is going to be equal to 1 over 2, the area of the trapezium, the length of the parallel side. This is 70. Sorry, this is 50 because it's going to be 70 minus 20.
Mhm.
Are you getting me, Derek?
Yes.
70 minus 20. Oh, this is 50 plus 30. T plus 30 minus t. That will be 30. This length is 40, and this is 50. Multiplied by v. So we should be able to find v. That is going to make our life easier than just finding the acceleration, and we're going to find acceleration anyway. So did you get to this stage, Derek?
Yes.
Okay. So 1,500 times 2, that is 300 minus, I think, sorry, divided by 80. That should be
About 33.3.
33.3. No, divided by 80. 80 is even, so I should be looking at 0.5 something something. 0.3 is some way. Try again. Try again. 1,500 times 2 divided
Um,
by
18.75.
18.75. No, I just used my calculator. I'm getting 37.
1 times
How are you
2.
doing it?
37.5.
Hey, Derek, is everything okay?
Yes.
Okay. So a V is 37.5 meters per second. Now let's go back to the question which said that the acceleration is 3 times the deceleration. So acceleration now, instead of the TV, I can now say that the A is equal to changing the V is 37.5. I can say 37.5 minus 0 over t minus 20. Are you getting it?
Mm.
Okay, so this is 37.5 over t minus 20. Now let's find the deceleration. I found acceleration. Let's find deceleration. The deceleration. this is going to be equal to, and the same, but this case, this is t plus 30 for the time component, and the velocity is 37.5. At this point, the time component is 70, and the velocity is, 0. So change in velocity, there's going to be 37.5 minus 0 over t plus 30 minus 70. Is that okay?
Yes.
37.5 over t minus 40. T minus 40. So now let's solve the question. We were told that acceleration, you know that this value is going to give us a negative. This
Yes.
deceleration, you have to get negative. So a is equal to 3d, but acceleration can be negative. So for this value to be an acceleration function, we can say that a is equal to negative d. Acceleration is equal to negative of deceleration. Do you agree?
Yes.
So I can say that a is equal to negative 3d instead of a equal to 3d, because this value is going to give you a negative. And if I'm saying that acceleration is 3 times of deceleration, and I finally get my answer as negative, acceleration to be negative, you should know that you're talking about deceleration, which is not true. So in raw fact, a is equal to negative 3d. I can put in the values and I'll be good to go. 37.5 over t minus 20. This should be equal to 37.5. Interesting. Over t minus 40. Is that okay?
Yes.
Okay. So we should be able to solve for this one, and we'll be good to go. Three times, Derek. I left it 3 times because this could have been so easy. Derek,
Yes.
so there's 3 times of that. So with this one, you should be able to solve and get me the value of t. I left it 3 times. Okay, so let's solve it bit by bit. The first thing I want to do is to expand. Let's expand the bracket. So 37.5 over t minus 20. What is negative 3 times 37.5? Hello there.
Yes, it's 112.5. Negative 112.5.
Okay. Over t minus 40. Okay. So from there, I can cross multiply. That's 7.5 t minus 40 is equal to negative 1125.5 times t minus 20. Okay, let's expand again. That's 7.5 t minus, that's 7.5 times 40 times negative 40. Hello?
Yes, sir.
Yeah, that's 7.5 times negative 40.
Times negative 40. minus 1,500. Oh,
Okay.
wait, no, it's
Okay.
2,250.
That's 7.5 times 40. That's 1,500. Hello, Derek.
Yes, sir. Okay.
You're really getting the numeric calculation wrong. What is wrong?
Um,
Is this one that is 2,250? Eric, is everything okay?
yes, I'm fine.
Let's group like tens. Let's group like tens. That's 7.5 plus 112.5. This should be 150. So 150. This should be equal to 2250 plus 1500. This should be 37, 3,750. And dividing both sides by 150 should be 25. So the time is 25. So at this time, the acceleration is 3 times the deceleration. But the question never said we should find time. The question told us to find acceleration. So let's find the value of A. Let's find the value of A. So from this side, we said A is equal to, that's 7.5 over T minus 20. And now we're getting A to be equal to T to be equal to 25. So A now becomes, that's 7.5 over 25 minus 20. That's 7.5 divided by 5. That will become the value of A. And this should be 7.5. So there's the answer to the question, 7.5 meters per second squared. So what did you do to get this one wrong?
Um, I didn't use the T and the T plus 30.
So what were you using?
I did it as like 10 10 at both sides.
10 10. Oh no,
Yes,
you can't assume the value. No. You didn't know, see, you don't know that value. So you can't assume that it's going to be 10. No, that is very wrong. Are you getting me?
yes, sir.
Okay. Okay, so let's solve the last question, then we are good to go. That's the sketching aspect of the question. I think there was a sketching aspect of the question.
Yeah.
Okay, so sketch a displacement time graph for the motion of the car. Hey, I think we did the motion of the car. This moving between graphs. Finally, yeah, this is the motion of the car.
Mm.
The graph in red. Are you getting me?
Yes.
You remember movement between graphs?
Yes.
Okay. So let's set this one up. Let me change the color. This will be the last question so that you prepare for your pure math class.
Mm.
Okay, motion between graphs. Sorry, moving between graphs. The first aspect, there's a velocity time graph. The first aspect represents constant acceleration. How do you represent constant acceleration on a displacement time graph?
Um, it will be a curve like this.
Yeah, it seems to be a curve. Okay, so this is the first part, and the motion between this was, I think, for the first 10 seconds, right? But
Yes.
yeah, for the seconds. So let's do that. What was the distance traveled in the first 10 seconds? I think we can calculate. I think if you calculate,
150.
you calculated for this in the beginning, 150. The next one, a flat line with no gradient, a zero gradient. What does it represent?
Um,
in a velocity
That one
time,
represents
constant velocity.
constant velocity.
How would you represent constant velocity in a displacement time graph?
That one, it will be positive gradient line, like straight line.
A line with positive gradient. Okay. Yeah. So that is that. And that one took us to 40
Yes.
seconds. Let's get this one over with. Okay, so there's 40. And what was the total distance traveled at this time?
1050.
Okay, so this will be 1050. 1050. And finally, this aspect of the curve, the last aspect of the curve,
Yeah.
let's use green. This aspect. What does it say?
That one is constant deceleration.
Good. Constant deceleration. So this is also going to be a curve like something.
Yes.
So a curve like it goes up and starts to bend. Yes, so that is constant deceleration. So at this side, the time traveled was I think 70.
Yes.
So okay. Okay. So the time traveled was 70, and the total distance was 1,500,
500.
and that answers the question. So this was what I was talking about when I was talking about movement between graphs. That's my very first question. I've seen in the past question. So it's very important to know what the shape of the curves are. Like how many marks for this?
3.
3. If you know what you are doing, it's a cool job. You don't even need to solve the second aspect correct. You can still
Yes.
get this one correct. Are you getting me?
Yes.
We have still gotten this aspect correct, and we're good to go. So we solved all the 10 questions. Uh, yeah. So what I would like you to do is to practice on the winter 2017. You've
Mm.
got this question. I think you took a picture of it. You took
Yes.
a picture of it as well.
Yes.
So it's still because of time, we can't, or maybe we can solve one. Maybe this one looks easy. 2016. It looks easy. Yes, we're able to solve this one. 2016 winter 4-1 question 5.
Yes. This was the one that it was the II part that had the forces inside.
Yeah. It's not actually forces, work energy and power.
Okay.
That is the work energy and power. That question wasn't so difficult. The work energy and power question about that wasn't so difficult. So let's solve the first two so that we just forget about the work energy and power aspect. When we get there, we'll solve it. Okay.
Mm.
We are not yet. That is the last thing you're going to do under mechanics. So the diagram above shows a velocity time graph which models the motion of a cyclist. The graph consists of 5 straight line segments. The cyclist accelerates from rest to a speed of 5 meters per second over a period of 10 seconds and then travels at this speed for a further 20 seconds. The cyclist then descends a hill, accelerating to speed v meters per second over the period of 10 seconds. The speed is maintained for the further 30 seconds. The cyclist then decelerates to rest over a period of 20 seconds. I find the acceleration of the cyclist. But Derek, the first aspect was just talking about the graph. You could have said this without the question, right? All that over there.
Yes.
Do you remember there was a time that I gave you the graph for you to describe the graph?
Yes.
Yes. So yeah, you could have said all this without even the question providing that to you. So let's
Mm.
find the acceleration of the particle. It shouldn't be difficult. I think the acceleration will be 0.5.
Yes.
10. So A, let me use a difference in maybe blue. Let me clear this. A is equal to 5 over 10. And interestingly, someone will write 0.2. It's normal. 0.5 meters per second squared. Okay, the next part is show that the total distance traveled by the cyclist in the 90 seconds, blah, 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 of motion may be expressed as 45. Okay, so the total distance, so S is equal to, now I can divide this one into 3 trapeziums. I don't like
Yeah.
the trans waste time. So let's say that the first one, this my trapezium 1, this is my trapezium 2, and this is my trapezium 3. So let's find the area over there. So 1 over 2, the sum of the power sides, there's going to be 30 plus
Plus
20
3.
times 5.
5.
We didn't find V, so we'll be able to find, okay, times 5. That's the
Mm.
first one.
Yes.
Plus 1 over 2, the sum of the power sides again. This is 30, sorry, this is 5 and V.
5 plus V.
So 5 plus V times
10.
10. And let me shift this one to the side. And the next trapezium is going to be,
Of
yeah, 1 over 2. 1 over 2, the sum of the power sides. This is going to be
30
90 minus
plus
40, 50. 50 plus 30.
yes. Times V.
Okay, all right. 30 times V. Okay, let me shift this. I think we don't need that aspect again, times V. Okay, let's simplify this. S equal to 1 over 2. This is 50 times 5. So let's say 5 over 2. I can write all this as 5 over 2 instead. 5 over 2, 5 over 2 of 50. Is that okay, Derek?
Yes.
Plus 5 of 5 plus V, because 2 will divide the 10 and you get 5. Plus V over 2 of 80. I could have written 40. So this divides that to be 25. 5 times 25. And this I
What?
can explain 25 plus 25V. Sorry, plus 5V, not 25V.
Plus
Plus
40 V.
V. So basically, at this point, I just go to the question and just write the answer over there because we are told to prove. I don't really need to prove this one. So I know I'm going to get 45V plus 150.
Mm.
So 45V plus 150. Did you get this one?
Yes.
Okay. Okay. Now, afterwards, we were told to find the value of V if the total distance traveled is 465 meters. So we are told that S equals 465. So I can now continue by saying that 465 is equal to 45 V plus 150. And this, you do your manipulation. 465 minus 150. 465 minus 150. That should be 306. Hey, how did this give me 306?
It's not what 315.
465. I wrote 456, sorry.
Um.
Okay, so that's 315. 315 is equal to 45 over V. So dividing both sides by 45, and she gets the velocity to be 7 meters per second. And that is interesting. So this question wasn't so difficult, right? It wasn't so difficult. I
Yes.
don't see any difficulty level in this. Maybe the other aspects would be the tricky one. Like I
Mm.
said, that is the aspect majority they've got problems in. Okay, so that is the first 11 questions. We're not going to solve any other question again. I think this one we've already done it.
Yeah, we've done it before.
Done this one already. So we're done with the 2016 and 2018 winter questions. So what I intended to do was to solve the 2017 questions as well. So try the 2017. I think the past question I gave you, it wasn't there. So download the past question.
Okay.
So 2017, solve all the kinematics questions. The next time we meet, you solve all of them. So 4-1, 4-2, 4-3, let's solve all the kinematics questions. Or you can also take a picture. Just take a picture of it.
Okay, I've done it.
You've done this one. Okay.
Yeah.
So let me, second one, 2017 winter 4-2 question 3.
Okay, I've done it.
2017 winter 4-2 question 4.
Okay, I've done it.
2017 winter 4-2 question 7.
I've done it.
2017 winter 4-3 question 5.
I've done it.
And 2017 winter 4-3 question 6. This will be very interesting. I've not solved the question, but I know it's going to be very interesting.
Okay.
Okay. So that is all for today's class. Just rest more so that you have your pure maths class. Okay. So take care. Get well soon. Okay.
Okay.
Bye.
Bye.